Welcome back to our session, children. Children, till now we have covered so many important theorems and similarity criteria of chapter triangle. Now we will left with only one important theorem, that is Pythagoras theorem of chapter triangle. So in today's session we will cover this important theorem, that is Pythagoras theorem. Along with this Pythagoras theorem, we will also prove converse of this Pythagoras theorem. And let me tell you one thing in advance, children, we have already proved all the similarity criteria, but that is just for your understanding. You only have to see the statements and we will only apply the similarity criteria. The proofs are not there in your syllabus. But before we will start Pythagoras theorem, children, there is one more important theorem, theorem 6.7 in your book, that is very important. See, the proof of the theorem is not there, it is not a part of your solution, but it is very important to understand this theorem, as we are going to use this theorem in the proof of Pythagoras theorem. So, what this theorem 6.7 says, that if a perpendicular is drawn from the vertex of a right angle of a triangle to the hypotenuse, then triangles on the both side of the perpendicular are similar to the whole triangle and they are similar to each other, which means if we have a right angle triangle ABC and if we draw a perpendicular from the vertex where is 90-degree angle is formed, from that vertex if we draw a perpendicular to the hypotenuse, that is the longest side, then this perpendicular, you can see the two triangles are formed, then according to the theorem both the triangles are similar to the whole triangle, that is ABC, the big one, and they are also similar to each other. Again I am reminding you, this is one of the very important theorem in the proof of Pythagoras theorem. So, let us start with the proof of Pythagoras theorem. So, children, Pythagoras theorem, we are very much familiar with this theorem because we are using Pythagoras properties since class 7, but the proof is here. The theorem says that in a right angle triangle, remember this is very important because this is only applicable when the triangle is a right angle triangle. So, in a right angle triangle, the square of the hypotenuse, that is the longest side, is equals to the sum of the square of other two sides, that is the base and the perpendicular. So, this triangle is given to you, triangle ABC, and this is a right angle triangle, right angled at point B. What we have to show, that the square of the hypotenuse, that is AC square, is equals to AB square plus BC square. So, as you know, we will always start with the given things. Write down ABC is a right angle triangle, right angled at B. What we have to prove? We have to show AC square is equals to AB square plus BC square. Now, children, we are doing one construction here. From vertex B, we are making perpendicular to the hypotenuse, that is AC. So, draw BD perpendicular to AC. Now, since we are going to start with the proof, it is given to you that BD is perpendicular to AC, and just in the previous session we have discussed, when a perpendicular is drawn from a vertex to the longest side, then that perpendicular that divides a whole triangle into two triangles, and both the triangles are similar to each other and they are similar to the whole triangle. So, use this concept here. I have written the theorem here. Now, see, according to this theorem 6.7, this triangle ABD will be similar to the whole triangle ABC. So, we have written triangle ABD is similar to ABC, but remember the naming of the triangle is very important. Now, since the triangles are similar, we know we can use or we can show that their sides are in proportion. So, write down carefully, AD upon AB will be is equals to AB upon AC. So, that selection of sides are very important. Also, this triangle BDC, this is also similar to the big triangle ABC. So, triangle BDC is similar to triangle ABC. So, again when they are similar, you can write that their sides are in proportion. So, write down BD upon AB, or you can write any combination. So, here the combination which we are using is CD upon BC is equals to this BC upon A C, right. So, again I am reminding you that the selection of side is very, very important here. Now, children, see the first step. When you are doing cross multiplication, you will have AD into AC here and AB into AB become AB square. Similarly, in this step when you do cross multiplication, you will have CD into AC is equals to BC square. So, this is your equation number 1, this is your equation number 2. Now, in the next step, add equation 1 and equation number 2. So, add them very carefully. When you are adding left side, you have AD dot AC, dot means multiplication, plus CD dot AC is equals to AB square plus BC square. Now, you can see here in this step what is common. You can see both the terms are having AC as a common term. So, you can take out AC out of the bracket. So, AC, when you have taken out AC, you left with AD plus CD is equals to that right side will remain as it is. Now, see the diagram. We have in a bracket AD plus CD. What is AD plus CD gives you? It will give you whole AC. So, replace this bracket by AC only. So, you have AC into AC is equals to AB square plus BC square. Now, AC into AC gives you AC square. So, we got AC square is equals to AB square plus BC square. Now, see the triangle again, AC is your hypotenuse. So, what we are showing that the square of the hypotenuse is equals to sum of the square of other two sides. So, children, with this we have proved Pythagoras theorem which says that the square of the hypotenuse is equals to sum of the square of other two sides. After this, we will be going to discuss about the converse of Pythagoras theorem. Now, in Pythagoras theorem, the thing which is given to us that the right angle triangle is there, and what we are showing that the square of hypotenuse is equals to sum of the square of other two sides. Now, converse will be vice versa of each other. Vice versa means in converse, now it is given to you that the square of one of the side of a triangle will be is equals to the square sum of the square of other two sides, and what we have to prove that the triangle is a right angle triangle. So, let us start with the converse of Pythagoras theorem. So, as I told you, converse means in a triangle. Remember, in case of Pythagoras, the term they are using in a right angle triangle, and here they are only using a term in a triangle. In a triangle, if square of one side is equals to sum of the square of other two sides, you have to show that the triangle is a right angle triangle. That is what we have to prove in converse. So, now we are going to do this in few steps. Step number 1, children, you are given with the triangle ABC, that is it. And the another thing which is given to you that the longest side here we are assuming as AC. So, it is given to you that AC square is equals to AB square plus BC square. And what we have to prove? We have to show ABC is a right angle triangle, means any of the angle of this triangle is a 90-degree angle, right. So, we have to prove, let us say we have to show angle B is of 90 degree. And now, we are going to do one construction. We are making one triangle here, say triangle PQR, but we will make triangle in such a way that this is a right angle triangle, right. We are making one right angle triangle, right angle at Q. And other thing here, this PQ side is equals to AB and this BC is equals to QR. This is your construction, right. I am repeating again, we are making a triangle PQR which is right angled at Q such that this side PQ is equals to AB and BC is equals to QR. So, let us start with the proof now. Children, this triangle PQR, because of construction, it is a right angle triangle, and since it is a right angle triangle, it means Pythagoras property is applicable here. So, what you can write in triangle PQR? In triangle PQR, we can write that PR square will be is equals to PQ square plus QR square, that is because of Pythagoras property. PR square is equals to PQ square plus QR square. But because of construction, it is given to you that this PQ is equals to AB and QR equals to BC. So, now replace these two things in the given equation. You will get PR square. PQ we are going to replace by AB and QR को BC square. So this will be your equation number 1. Square of PR is equals to square of AB plus square of BC. Now come to the thing which is given to you. You are given with AC square is equals to AB square plus BC square. Now carefully observe both the equation. If you see, the right side of both the equations are equal, and when the right sides are equal, you can also equate their left side. So what you will have? PR square is equals to AC square, and the square and square get cancelled from both the sides. So we left with PR is equals to AC, right? Now come to the last step. Children, what we have just shown, that PR and AC are equal. Now see the diagrams again. In this diagram, because of construction, PQ side is equals to AB. Because of construction, BC is also equals to QR, and just now in our previous step, we have proved that AC is also equals to PR. So it means when the three sides of first triangle R is equals to three sides of the second triangle, means the triangle become congruent under criteria SSS, congruence criteria. And we know when the triangle become congruent, all their corresponding parts are equal. So we are showing that the triangles become congruent, and since their corresponding parts are equal, so we can equate angle B and angle Q. So we are writing that angle B is equals to angle Q. But now what is the value of angle Q? Angle Q is 90 degree, right? That's because of the construction. So we can write angle B is also of 90 degree, and hence we have shown that if in a triangle, if the square of one of the side is equals to sum of the square of other two sides, then the triangle is a right angle triangle. After this, children, we are going to practice few examples which are based on Pythagoras theorem as well as on the base which are based on converse of Pythagoras theorem. So let's start with the examples now. Example number 1 says a ladder is placed against a wall such that its foot is at a distance of 2.5 meter from the wall and its top reaches the window 6 meter above the ground. Find the length of the ladder. So children, here we have to draw the diagram. Let us assume that this AB is a ladder and it is placed against a wall, and there is a window which is 6 meter above the ground, and the distance between the foot of the ladder and the wall is 2.5 meter. You need to calculate the length of the ladder, that is AB, that you have to find out. So write down, you know the things which are given to you, just write down the things which are given, and clearly children, if you see this angle, here you will get a 90 degree angle. It means if this forms a right angle triangle, and when it becomes a right angle triangle, Pythagoras property is applicable here. So you can apply Pythagoras property here, and accordingly what you can write, that the square of AB square is equals to AC square plus BC square. So just put the values. BC is given to 2.5 square and AC is 6. Now 2.5 square is how much? It is around 6.25. 6.25, and to this you are adding square of 6, that is 36. So when you add them, you will have 42.25. This is equals to AB square, right? So now when you remove this square, you will have root on this number 42.25. Children, find the root of this number. It's your choice. If you want, you can do long division or you can do prime factorization to find the root, and here you will see that AB is equals to 6.5 meter. It means the length of the ladder is equals to 6.5 meter. Let's start example number 2 now. Your example 2 is based on the proof. Here it is given to you that this AD is perpendicular to the side BC of a triangle ABC, and when we are using term perpendicular, means by default 90 degree angle is formed. What we have to prove? AB square plus CD square, this side square plus this side square, is equals to BD square plus AC square. This is what we have to prove. Okay children, so you can see when AD is perpendicular to BC means it becomes a right angle triangle. So let's take both the right angle triangle one by one. First we are taking triangle ADC which is right angled at D, and by using Pythagoras property, see if 90-degree angle is formed here, then which one is the longest side? It is AC square. So write down using Pythagoras property, AC square will be is equals to AD square plus DC square. That will give you your equation number 1. Similarly, if this angle is 90 degree, obviously this side also will be 90 degree angle. So now use Pythagoras property in triangle ADB. This is your longest side, that is AB square is equals to BD square plus AD square. That is your equation number 2, right. Now what we have to do in the next step, we are going to subtract equation number 1 from equation number 2, right. So we will have AB square minus AD square is equals to, carefully subtract right side as well, you have DB square plus AD square, and when you are subtracting this sign, remember you have to change the sign of the whole bracket. So when you write this, and in the next step when you open the bracket, the sign of AD square and DC square get changed. So you will have AB square minus AC square is equals to DB square plus AD square. Now this become negative AD square and this is also negative DC square. Children, positive and the negative term get cancelled and we left with AB square minus AC square is equals to BD square plus minus DC square. So now do the transposition, bring this DC square from right to left, and when you are shifting them, the sign become positive. So here we have AB square plus CD square, and now shift this AC from left to right, again it become positive. So here we have BD square plus AC square, hence proved. Now let us see the third example. So children, the example says a gay wire is attached to a vertical pole of height 18 meter and the length of the wire is 24 meter. In this you have to calculate the distance of the foot of the wire and the foot of the pole, that is AC. Clearly you can see here at point C 90 degree angle is formed. It means ABC is a right angle triangle, and when ABC is a right angle triangle, Pythagoras property is applicable here. Now angle C is 90 degree, it means which one is the hypotenuse? It is AB square. So what we can write? We can write AB square is equals to AC square plus BC square. Now substitute the values. AB square is square of 24 is equals to AC square as it is, as the value of AC is we have to calculate, and square of 18. So now do the transposition. We can write AC square is equals to 24 square minus 18 square. Now square of 24 gives you 576 minus this is 324. Now after doing subtraction you will have 252. Now children, this is AC square is equals to 252. So now when you remove the square from the one side, you will have root on this number. So children, I know the answer, but I am leaving this here only. You have to do prime factorization and you have to give answer yourself and calculate the length or the distance between the foot of the wire and the foot of the pole. Now next question is, two poles of the height 6 meter and 11 centimeter stand on a plain ground, and if the distance between the feet of the poles is 12 meter, find the distance between their tops. So you can see the diagram, there are two poles, say this is AB and the length of the bigger pole is 11 meter, and there is another pole CD and the length of that second pole is 6 meter. Now it is given to you that the distance between the foot of the pole is, feet of the pole is 12 meter. We have to find out the distance between their top, that is A is the top of the first pole and C is the top of the second pole. So you need to find out distance between them, that is length AC. So children, how we are going to calculate this? We will see the diagram only. See, these two lines are parallel. So if this is 12, this will also be 12 meter only, that is EC will also be equals to 12, and if this whole length is 11 meter and from here to here it is 6 meter. So what can you say about AE? This whole is 11 and from here to here it is only 6. What can you say about AE? It is 11 minus 6. 11 minus 6 gives you 5 meter. Alright. So, we will write down AB is equals to 11 meter and AE will be is equals to 11 minus 6, that is equals to 5 meter. Now, if you see this triangle again carefully, you can see a 90-degree angle is formed here, means Pythagoras property is applicable. So, AC square will be is equals to AE square plus EC square. Write down this, AC square is equals to AE square plus EC square. Substitute the value, it is square of 5 plus it is square of 12. So, 5 square gives you 25, 12 square gives you 144 and their sum is going to give you 169. So, AC is equals to square root of 169, that is equals to 13 meter. It means the distance between their feet is equals to 13 meter. Now, let us start the next example. Children, this is one of the question of your exercise only, one of the very important question. You will get this question for either for 3 number or for 4 number. Now, the question says that there is an equilateral triangle ABC. Equilateral triangle is there, means all the sides of the triangles are equal and there is a point D on side BC such that this BD is equals to 1/3 of the side of side BC. This relation is given that this BD is 1/3 of BC. We need to prove 9 AD square. This 9 AD square is equals to 7 AB square, right? So, let us start with the proof. Write on the given things. It is an equilateral triangle with all the 3 sides are equal. AB will be equals to BC is equals to AC. All the 3 sides are equal. Another thing given to you, that is BD is 1/3 of BC. Now, we have to prove 9 AD square equals to 7 AB square, that we have written here. Now, after this we are going to do one construction. In construction, we are making let AL is perpendicular to BC, that is your construction, and when it is a perpendicular, no doubt an 90-degree angle is formed at point L. Now, see, if children this AL is perpendicular to BC, what can you say about length BL? It is a right angle triangle, means it becomes a perpendicular bisector as well. So, what can you say about BL and LC? No doubt it will bisect this BC into 2 equal parts. So, BL will be half of BC. BL is equals to LC is equals to half of BC. And second thing, this is given to you that BD is 1/3 of BC. So, if BD is 1/3 of BC, what can you say about DC? This whole length is BC. If this is 1/3, what about this side? This will be 2/3 of BC. So, this is equation number 1, this is equation number 2. Now, remember this question in a steps only. You can see first I am going to apply Pythagoras property in triangle ALD, this small one, right, and after this I am going to apply Pythagoras property in triangle ALB one by one. So, when I am applying Pythagoras property in the small triangle ALD, what we can write? AD square is equals to AL square plus DL square, that is your equation number 3. And now, apply Pythagoras property in this big triangle. So, what you can write? AB square is equals to AL square plus BL square. So, that is your equation number 4. Now, after this subtract equation 3rd from equation number 4 and subtract very carefully, because we have to subtract left with left, right with right. So, here we will have AB square minus AD square, and this side, see, when you are subtracting this to equation, children, AL square plus BL square minus AL square minus DL. So, AL and AL get cancelled on doing subtraction and we left with BL square minus DL square. If you see this step carefully, this is in the form of identity number 3rd, and identity 3rd says A square minus B square is equals to A plus B, A minus B. So, open this by using identity number 3rd. We can rewrite this equation as BL plus GL, that is A plus B, BL minus GL, that is A minus D. Now children, after this just substitute the values of the things which you have already found in your equation 1 and 2. But, BL is equals to 1 by 2 BC, that we will put here. Now DL, see the diagram, DL, we will replace this DL by BL minus BD. You can check this from the diagram. I am repeating again, this DL can also be written as this whole BL, and from this we will subtract BD. And now the second bracket is BL minus DL. BL minus DL gives you what? It gives you BD. So we will replace this by BD now. Now put the values, this is half BC, BL is also half BC, BD we have already calculated, that is 1 by 3 of BC, BD again 1 by 3 of BC. Now here in this equation children, you have to take the LCM 2, 2 and 3. The LCM will be 6. Solve this bracket, you will have 4 by 6 BC, and in the simplest form 4 by 6 gives you 2 by 3 BC. Along with you have another thing BC upon 3. So now you have BC into BC gives you BC square, 2 will remain as it is, and 3 into 3 gives you 9. Here we have AB square minus AD square, and this is equals to 2 by 9 BC square we are getting. So in the next step children, we will shift this 9 from the right to the left, and we will have 9 AB square minus 9 AD square is equals to 2 BC square. Now again we are doing transposition children. So we have 9 AB square minus, see this BC is also is equals to AB, as all the sides of a triangle are equal, this is an equilateral triangle. So this BC we will replace by AB, shift this BC from this side to this side, you have 9 AB minus 2 AB square, and when you are shifting this 9 AD square, this negative become positive. So 9 AB square minus 2 AB square gives you 7 AB square, and that is equals to 9 AD square. So children, we have covered all the examples of Pythagoras theorem. So children, in this way successfully we have completed our chapter 6, that is triangle, and we have covered so many important things about chapter triangle. We have started with basic proportionality theorem, its converse, then the criteria of similarity, then after that we have discussed area theorem, we have also discussed about Pythagoras theorem and converse of Pythagoras theorem. One of the very important chapter of your book, and the weightage of this chapter is also very high. So children, keep doing practice, keep solving some questions and stay connected. Thank you so much.